Well, good morning, everybody. Just two quick announcements before we get started today. One, the website's back up functioning, got the European model situation figured out, also fixed 3 other data sources. We're all good to go. Head on over to ag-wx.com to check out all my maps, all right? Second thing is, I apologize for the way I sound. This is day 4 of me battling this cold this week, and I'm just trying to recover here, so my voice is a little bit messed up. But I've got a lot I want to share with you today. We're going to walk through a long-range forecast all the way through winter. We're going to talk about forecast verification, some of the big drivers this winter. Then we're going to do the near-term forecast and look at the latest updates on this snowpack. So if you don't have a lot of time today, grab the bar at the bottom of the YouTube video and slide it over to the part that you want to see, okay? Because I want to cover a lot with you all today. First things first, we watched this upper level low that moved over parts of the Great Lakes last night, continued to spread some decently heavy rains throughout parts of kind of the eastern Great Lakes down here into the eastern Corn Belt, and the main frontal boundary stretched pretty far to the south. This system is going to continue to curl up this weekend over parts of New England and locally deliver some pretty heavy rainfall, while the rest of the country kind of goes a bit into reset mode. We're kind of preparing for the next big system we've been talking about all week that's going to show up midweek next week. So just to kind of give you an idea on total accumulated rainfall here just over the last 3 days, okay, this is that system as it rolls through. And like I said, some places here really kind of outperforming some of the original forecasts with better than an inch falling across a broad section here, the eastern Corn Belt. Now, what's so important about this is that when we look back statistically on how much precipitation has fallen since September 1st, this map shows us the total precipitation ranks by climate district since that time frame. It kind of begs the question of how well did the models perform in predicting this? Because we watched drought expand throughout parts of the Ohio River Valley and the Great Lakes, throughout the Tennessee Valley, over toward the Appalachian Mountains, and of course, down here in the lower Mississippi River Valley. All of that while the Northwest was wet. Much of the northern tier of the United States was wetter than average, while the Southwest continues to wait on better moisture. So we look at this and say, all right, could we even predict the last 50 days versus what I'm going to show you here in a little while, which is a prediction all the way out to, next February. So let's kind of talk about this a little bit. First thing is, if we were to use El Nino as our only indicator, all right, and pick out those years, September and October, when we had El Nino events like ones that are building like we have now, we would have projected wetter conditions here, wetter conditions from Texas all the way over to the Appalachian Mountains. Of course, we didn't have that. Been drier in Florida, drier in New England. We're not looking at that either. And near normal precipitation for the Pacific Northwest. It was actually much wetter than average, at least wetter than expected to this area. And it would have been drier there. So you can see that El Nino right now, we're going to run into this trap. Many of us meteorologists are going to run into this trap of wanting to over-accredit El Nino by pulling out analog years and say, this is the last time we had one. This is what we should expect. We can't do that. El Nino is our big seasonal factor. It's there. But these sub-seasonal things seem to be dominating the pattern, as they always do. Just remember, El Nino's kind of the steering current in the bigger picture, but it's the little fluctuations on shorter time scales that ultimately dictate what's going to happen. So keep that stuffed away in the back of your mind. Because had this had happened, I wouldn't be looking at, a soil moisture map from September 1st, still looking like this on October 20th, right? We would have seen massive improvements across, these soil moisture values here throughout the Mississippi, Missouri, and Ohio basin. But as it stands, the Mississippi River this morning was at 11.5 feet below low stage, still in record territory. It dipped down there to 12 feet below low stage earlier this week. And even with some of the recent rains, like a week ago, that hit a major part of the Mississippi Basin watershed, it wasn't enough to undo the long-standing problems, and the flow hasn't increased because of that. So we get our new drought monitor yesterday, and it still shows about 60% of the land area in the lower 48 in some form of drought. And we watch drought expand primarily in this region, parts of the eastern Corn Belt here. But this is a lot of drought to undo over the winter. And we have to ask that question, is the atmosphere capable, given what it's currently up to undo this? So here's your big drivers. We keep talking about these, but we've got a lot of warm water in the Atlantic. We have our El Nino event, which is right in through here. The trade winds have been weaker. We've seen our best rising motion in here. A lot of sinking motion in the atmosphere there. Better rising motion. Whoops, should probably put a circle around that. Better rising motion here. The Indian Ocean dipole is still, I think, the most dominant teleconnection. Spent a lot of time in the last 2 weeks talking about that. But this negative PDO signal, the cooler water here, the negative PMN signal here, that's the Pacific Meridional mode. I think these two features, which are sub-seasonal, especially the PMM, are going to be important to watch as we see where the jet stream is going to line up here in the next, 4 or 5 months. Now, real quick, I may have misspoke there. I said the PDO is a subseasonal. It's not, okay? The PDO is a decadal setup here. So, but we're just seeing this cooler water enhancing it on a subseasonal timescale. Does that make sense? So these are still the big things that we're going to continue to watch as we go forward. So here's what I'm going to do with you. Last year, what happened? Can we verify last winter as a way of thinking about this winter? So I save all this stuff. So I pulled it out of my archive and said, well, what did the models last October say that December, January, February of 2022 to 2023 was going to look like? And the general consensus was if you were south of this line, we were going to be drier, very active Pacific Northwest, very active Ohio River Valley, good snows throughout the Canadian prairie and possibly in the northern tier of the United States, but drier south. That was the prediction. That same prediction was echoed by the National Multi-Model Ensemble. This was, again, last year in October, the prediction by the NMME, looking at December, January, February. Notice the same things, wetter, drier south of that line. And we can even go back and ask the government what it said. And this is what it had. This was, again, released in October. Actually, this was released in November. Forgive me. That was even a month later. Still the same thing. Drier south of that line, active Northwest, active Ohio River Valley. That was the consensus. And we say, well, why was that the consensus? Well, what we had was a La Nina. And I'll show it to you in a few moments. But if you want to verify this, we were drier in the Northwest, drier Texas, drier Florida. Very active in California. In fact, we destroyed a drought in California in essentially 4 weeks. The first 2 weeks of January, then in March, the first couple weeks of March. That's what undid all that drought. Very active in through here, but wet in the Tennessee Valley and wet in New England. So you look back and you say, all right, the models would have said, now remember this, that we would have been dry south of that line, active in through here, got that, active there. So what I'm trying to show you here is that the subseasonal factors outdid the big seasonal factor, which was La Nina. Because if you asked me to draw you in a textbook a typical La Nina winter forecast, I would just draw you this. That's what history would tell me. But it doesn't often verify perfectly because El Nino or La Nina on subseasonal timescales, well, even seasonal timescales, typically only verifies or has a correlation with the actual pattern of about 0.3. So it's not as though it's super high. By the way, remember last winter was the winter where we saw tremendous snow in the west. We filled up the Colorado River. We filled up the Sierra Nevada mountains. Some of the peaks in the Rockies hit 900 inches. And then the upper Midwest saw, some places had 50 extra inches of snow. And then you come right into this dividing line here. And if you were south of that line, we had rain, but we did not have snow. Where I live in Champaign, to have 9 inches on the season when normal's like 24 to 26, we were way off of average here. But we did see this. If you look at October 25th, a year ago in 2022, and then you compare it to what happened on March 7th after winter was done, this is what happened with our drought area. We had 86% of the country of the lower 48 in some form of drought. So let me rephrase that. 86% of the lower 48, because I'm not including Alaska and Hawaii in this calculation. And then by the time we get into March, we reduced that to 46%. So again, that was before winter, that was after. And I show you this because I'm asking the same question about this year. Can we get a massive reduction in drought? What does it take for the atmosphere to do it? Because we do not have La Nina, as you all know, like we did a year ago. But I can make an argument that last year's winter did not phase into a typical La Nina pattern. Because this is what typical La Nina looks like, and this is what the government forecast last year for the temperature pattern. And it may have verified here, but much of the rest of the country it didn't. In fact, take a look. This is how the pattern changed. From December to February 2022 to 2023, we should have split the country like this in terms of temperatures, not like that. And that's what we did. The forecast, I'm just showing you the government forecast, but every long-range model did this. Cold northern tier, warm south and east. It really only got it right here up the East Coast. So remember, these subseasonal factors have a major role, and I'm going to show you those in a few minutes. The big seasonal factor was this. Last October 18th, we had Massive El Nino event. Whoa, forgive me. Massive La Nina, the cold water here. Trade winds were screaming. And this year, we have this. So the Indian Ocean dipole a year ago, opposite phase. El Nino, opposite phase. This year, very positive Indian Ocean dipole, very positive ENSO event, which we call El Nino. And the Atlantic is so very warm. So given all of that, okay, given these factors, what do we know about this upcoming winter? Well, if we played the game and just said, all right, let El Nino dictate what's going to happen. December, January, February, we tend to be drier in the Cascades, Northern Rockies, Central Rockies, wetter coastal California. We then tend to see a very strong subtropical jet come underneath this and be wet in through this area, but dry in the Eastern Corn Belt. Like that's what El Nino, all these years that had El Ninos develop, would say about December, January, and February. Okay? The issue is that because El Nino, which is really being reflected in the ocean temperatures, a lot of folks will tell you this backwards, the ocean temperatures are responding to the trade winds. It's not that the trade winds are responding to the ocean temperatures, okay? The ocean temperatures responding to the trade winds. We look at the ocean temperatures as a symptom of what the atmosphere is up to. And symptomatically, if the ocean temperatures are showing El Nino, the trade winds are weak. Hence, the convection across the Pacific ignites the subtropical jet, and the flow comes over the top like this and meets up along the East Coast. So yeah, El Nino years, big East Coast snowstorms. They tend to give it to it. They tend to be drier and at times colder with each outbreak that comes in through this area. But you got convergent air through here, that's going to be drier. That's El Nino for you, all right? So what do the new models say? Well, does it not look very El Nino-y here from our government? They just updated this. This is the new CPC December, January forecast, December, January, February forecast. About the biggest difference here is that they're going wetter in California compared to climatology. They've got wetter conditions for most of our cotton belt down here. Drier Ohio Valley, drier Pacific Northwest. That is El Nino to the T. So is their forecast for temperatures. More mild days north, and near normal to cooler than normal temperatures to the south, December, January, February. Now, I want to be very clear about something. I'm not being critical of NOAA and the National Weather Service and the CPC. I have friends and former students and colleagues that work there, and I respect them more than I can explain to you in a video. We are just looking objectively at this forecast. It is in their best interest, and it is in mine, to tell you that because of these ocean temperatures, we should expect exactly what I just showed you here, here, and here. But history would tell all of us that the subseasonal factors, like the MJO movement, sea ice extent, Bering Sea low pressure development, the Atlantic, the North Atlantic, the Arctic Oscillation, the North Atlantic Oscillation, Siberian snow cover, all of these things, these subseasonal factors, and don't forget the polar vortex, can ruin this. Now, is there a chance that most of the places shown in red here over the 90 days that spans December, January, February do have more days above normal temperatures? Sure. But when it gets cold this year, these areas are going to see very sharp changes in temperature. But that's winter. I'm not telling anybody anything they don't already know about winter. But just so I'm clear here, are other models predicting this kind of precipitation pattern? Yeah. This is the European model. The only difference is it's drier in California, but it's the same wet area down here as the CPC's forecast. And what about the National Multi-Model Ensemble? They've got a very similar forecast as well. To be honest, this might be the one that I'm most in agreement with. Although I would say that I don't think the Pacific Northwest or the Northern Rockies are going to be as dry as currently advertised. And you might say, well, why? My answer for you right now is that we would have predicted them already dry, like already getting dry. And what's happened? They're not even there. They've been wetter than average so far since the end of summer and now, moving our way through fall. So I can't look at this and say, why would I all of a sudden flip this over only on El Nino? That doesn't seem like a wise, decision. We have another forecast to add into this. This would be the newest update from Columbia University. So this is their multi-model probability forecast system, and they're looking at December, January, February. And notice they're driest down here in parts of Mexico, wet up the East Coast all the way down to the southeast, but they're very limited and where they're predicting a higher probability of being drier than average. And I think that statistically, when they go and analyze all of the different models that go into the NMME, which is what they're doing here, they don't find enough consistency to make that call. Now, I've been telling you a lot about El Nino, and I want to make sure one thing's very clear about El Nino as you look at this. El Nino right now has been overpredicted for months. I mean, do you remember back in summer where I kept saying, hey, every forecast model wants to give us this super Nino? I went back to August 2023, and the forecast plume from the European model, which was the least aggressive. Still, if you found the average, it was sitting somewhere right in through here, I don't know, maybe right in through there, which is about 2.5 degrees C above average by the time you got into December. You see the dotted line? That's what's actually happened since August, meaning that every forecast has been overshooting how strong this El Nino is going to be. El Nino is still present, but what I'm saying is let's be careful not to over-attribute a winter forecast to its historical, historically what it's done, I guess is the way to think about it. So just an update here, the latest October outlook. Notice now that the ensemble plume, if you look at all of it, is going somewhere closer to 2 degrees C, not 2.5 or 3. So that means that this El Nino, if we don't see these really, really warm ocean temperatures, indicates that the trade winds are not like stopped and reversed. That's what happens in an El Nino. They stop or reverse. They're just going to be weaker this year. And that's going to influence a lot of things, or maybe let these subseasonal factors take over. Again, what are the subseasonal factors? Well, Arctic sea ice for one. You see that the contrast in temperatures in the Arctic from where there is sea ice to where there's open ocean dramatically affects the sensible heat flux out of the polar regions. And that's what sets up the polar vortex. So right now our sea ice concentrations, while they're lower, they're actually lower than average. They're actually higher than some of our most recent worst years. So understand that the sea ice in places in the Arctic is trying to fill in better than it has in some, really interesting years like 2017 or 2020 or 2012, which are these lower lines. Another subseasonal factor, I keep talking about it, but let me show you. As of October 19th, this is shading in where we've got snow cover. Now we've got decent snow cover across much of this side of Russia into Siberia, but it's the extent of this as it expands farther, over to the west in Russia, and then throughout North America, that's going to be critical. Now we have some snow coming for Canada, and by the time we get to the end of October, looking at the snow extent here, and then the sea ice here, will be critical to assessing how we're going to set up the polar vortex. Because right now in the polar vortex sphere of influence, we're just at the beginning. It's later on in the season when we get lots of variability in the polar vortex, especially weakened polar vortex time periods, that we get these massive outbreaks of colder air. You see, it's the sub-seasonal things that drive, the week-to-week variability. The background current is still El Nino. It's still the Indian Ocean dipole. It's still the warm Atlantic. But it's these sub-seasonal things we got to watch carefully. So if I'm painting a picture in your head of saying we don't yet know what winter is going to be, that's what I'm trying to tell you. So all of these definitive, forecasts that come out like on YouTube, like mine does, or on any social media channel that just claims that they've nailed it, I want you to understand that those forecasters in reality, if they're good, understand that there's so much uncertainty. And I've seen some of them that have conveyed that. So I just want to be clear on those things. So you ask me, well, Eric, what do I base anything on? What am I looking at? I'll be honest with you. My current forecast hangs more on persistence of what we've had over the last 35 to 40 days than any long-range forecast model. And my reasoning for that comes right back to this. This is how I look at the MJO. And I still think that right now, because we're not yet fully into the cold season, the tropics are the more dominant signal. And what I have seen and what it continues to be forecast all the way to the beginning of November is subsidence here, rising motion there, and rising motion here. Now, how many times have you seen me draw this? That's not to ignore the rising motion that's over here either. A lot of this is helping kick off like hurricanes, like Norma. But the reality is that if the MJO were moving, this shade here and these blue-greens would move across the image like this. And that would give us more variability in the pattern going forward, but they're not. It's straight up and down, and I want to know how long does the Indian Ocean dipole, which is giving us the strong trade winds this way, the rising motion here, come back across, the sinking motion there. Now do you see it? The rising motion in blue-green, the sinking in the red. How long does that continue to hold the MJO hostage, making sinking air here and rising air there? Because if that lasts all the way to the front half of winter, you just take what we've got now and amplify it going into winter. And if that's the case, then we're going to get into a pretty, rockin' winter overall. I look out there and I can see it like this. Even some of our other long-range models, that was the European. I'm going to show you the GFS ensemble. Same thing. See all the sinking motion there? Here's the rising motion. Here's the rising motion. So that's the signal that I am going to be watching to see if it gets stuck and stays. Because of that, this is the new November forecast from the European model. And I buy into this. And the reason why I buy into this is because if you combine what I just shared with you with some of those seasonal forecast factors, what would be there to stop the progression of storm systems like this? And what would be there to stop the opening of the Gulf of Mexico to provide the moisture into this area? And normally, as we get into, later into fall, through the month of November, we start to see the combination of the jet stream tending to favor, especially in an El Nino year, more southerly track. Let me show you this. I'll just open up another tab here real quick. One of my favorite sites. Let's see if I can help if I type the right thing. MPJ, there it is. This is from Albany. Let's look at the probabilistic forecast. Look at that. There's an equatorward shift of the jet right now. And if it does that, that means the subtropical component begins to become more invigorated. It means the whole North Pacific jet's dipping south. But if we get that subtropical component in, man, we're in business. This is going to get things cranking overall. So I look at this and I see something that makes sense to me for the month of November. And this is what I'm seeing. And on the temperature side of it, I don't understand a lot of these really warm forecasts for the West because of what I see here. This tells me MJO phase 1, phase 8, deeper troughs at times coming in here. They bring a warm air out ahead of it, quick transition behind it, but they move across the country. That's what I think is going to happen for the month of November. Now, our government released their newest forecast for November. They released this just yesterday. And they're seeing a warm-up for the West that I'm not seeing. And that's okay. We'll just watch and compare. They're probably seeing more Pacific air influence from the southern side of the Pacific. This is very El Nino-like start to our cold season, November, December, January, February, and March. So they're buying, I think, more into the story of El Nino controlling the pattern. They're certainly seeing that out there for the 3-month outlook. This is November, December, January. What I showed you earlier was December, January, February. If you don't mind, I'm just going to draw over the top of this, and I'm going to give you my current thinking on winter. Ready? Okay, so let's just draw on the precipitation side of this. Their forecast likely suggests split jet stream flow. So coming over like this and from the south like that. I don't think we're going to quite see that. I think this split is either going to be farther east or farther west. I don't think it's going to be here along the west coast. I think we're going to get more troughing in the west coast. So what I would say is I would eliminate this. I would still keep the wetter conditions across our cotton belt, but I would expand them into the Midwest as well. I think it's going to be later in the season that California starts to pick up moisture, but I have no concern about California developing drought this winter. I actually think the whole U.S. has a more active pattern that's going to take, the latest drought, which is at 60% coverage, and probably drop it below 30% by the end of winter. I'm expecting a lot of storm systems to start in the panhandles, start in the Arklatex region, start here around Paducah, start here around New Orleans, and then roll like this. I think we will see more limited clipper systems coming through because I don't think that the jet stream is going to enter the United States out of the Northwest. I think it's going to come in more like this. And if that's more westerly flow, then these longer range forecasts of being drier in those key areas that we showed you a moment ago likely won't verify. The new seasonal drought outlook, I do agree with this, although I don't think that we're going to see drought persist all the way up here into the upper Mississippi Basin. I think we will see major improvement in here. I completely agree with Noah on this. And we may end up being better for the Pacific Northwest. Certainly, we have under forecast the Pacific Northwest already this winter, or this fall. All right, so there you go. These are my latest thoughts on the long range. And we need to next week spend some time talking about other places around the world with respect to this as well, and I'll be sure to do that. But I do need to show you this. The CPC just released yesterday that they've got, for the end of October, pretty substantial risk from the 27th through the 30th of really cold air coming in. Now remember, this is next week, right? And on the chance of heavier rain, they've identified the Pacific Northwest and the whole of the southern part of the Mississippi Basin back into this section of the Mid-South and all the way into the Southern Plains. And on the snow side of it, the biggest change is they've just brought this back farther to the west, really anchoring it on the Rocky Mountains in Montana. So if that's what their new week 2 forecast looks like, remember this storm system starts about a week from now, maybe a week from yesterday. So here we go. This is what we're going to watch until then. System leaves New England today. Locally heavy rain there. Some showers come around the backside of this throughout Saturday, right here through the Great Lakes states. And there's Norma. Now we're going to get through Saturday, getting into Sunday, relatively for most of the country, uneventful. There's a little shortwave that sneaks through here, bringing in some rain into the Pacific Northwest. This is Sunday afternoon. We're going to watch the upper level low leave, but a lot of folks in the country not seeing much at all. Now, I parked this out here 5 days from now to make a point. This is the high over low block we've been talking about now for 10 days. It's there. It's still forecast 5 days from now, next Tuesday night. 0Z Wednesday's Tuesday night. This is what's critical. The ridge builds out ahead. That opens up and sets up the environment for a big storm system. The European model has a northerly wave and a cutoff low to the south. Now, the GFS wants nothing to do with this breaking apart of these two waves. The GFS says keep them together. The GFS is still on board with the wave that's on the backside, grabbing the wave that's on the south side, bringing them around, one orbiting the other, and kicking off a massive system in the Midwest. The European model separates them. Look at that. I mean, to the untrained eye, this looks like no major difference. You're just like, all right, I see a little bit of different shade of blue. But that difference right there means a coupling of two waves working together, and the European model suggesting that they don't. So what does this eventually produce? Well, let's go compare the model since I finally got everything working again. GFS left, European right. There's such good agreement through Saturday into Sunday. I mean, they both pull the same systems through New England, bring in the next wave into the Pacific Northwest, and try to take Norma here into this part of Mexico. This is the 72-hour forecast out there till Sunday at 7 p.m. Now, as we play forward, there's going to be a large high-pressure cell that builds along the East Coast. And that high-pressure cell is going to open up Norma, pulling it across Mexico into Texas. And we're going to see precipitation run along the western side of this, while the uncoupled wave in the European model comes in versus the more coupled waves here being closer together enter next Tuesday afternoon into the west. So GFS, European, ready? As we go forward, look at this. The GFS is trying to kick off this massive storm system here. Bigger snows on the backside, severe weather to the south. The European model, they're uncoupled, so the wave's still here. There's just flow coming around this ridge and heavier rain in between in this area. This is just next Wednesday. As we go forward, look at the size of that system moving through the country here next Thursday. Where's the European on it? It's not there because the two waves are not working together. So the GFS is our big snowmaker. It just rips out this path of snow that comes from the Four Corner States through Wyoming, Nebraska, South Dakota, Minnesota, and just keeps ripping that snow through. Whereas it takes a little extra time in the European model to take the wave and move it finally over to parts of Missouri and Iowa. And it prefers that the northern wave creates its own storm track through Canada. So that's where it produces the snow. Major differences in the models. And we've been looking at the performance statistics all week long. That's out 10 days. So what do we do with this? Well, let's compare them just out 7 days. The European model, if you see these colors, is wetter. So it's wetter all here where the high pressure cell sits and the rains just continue to run the periphery. The GFS is wetter where you see these colors. And that's because it takes one trough, two trough, they combine and produce a massive system in this area. Now that is the biggest contrast I've seen in a long time between these two models. And that's not to ignore other things like Norma or the Pacific Northwest or what's going on in New England. It's just looking at this combination of this system. So let's go ahead and look at some other stuff. 10-day rainfall from the GFS versus 10-day rainfall from the European. Look at that. 0Z runs, stark differences here in total precipitation. Gosh, that's amazing. And then we look at the snowfall side of it. Where's the European want the snow? Parts of Montana, but really it's going to go from British Columbia through Alberta into Saskatchewan and here into parts of Manitoba. Ready for the GFS? This is the new GFS run. Now, I imagine there's probably a couple thousand people watching this right now rooting on the GFS. Go for it. I would. Why not? This would be fantastic. I mean, fun for meteorologists, maybe not fun for everybody else. But just look at that snowpack coming in there. But remember, the GFS, that's the 18Z run. This was the 12Z run the day before, and this was the 6Z run before that. So remember, these models bounce around a lot. And since I've started recording, the 6Z runs fully come in as well. And it wants to back the snow back up into Montana and the Dakotas and then leave Minnesota out. So I need you to understand that there's still a tremendous amount of uncertainty. So we then go say, well, what about the ensembles? 10-day probability of an inch right here in the European model. This is the GFS. So you notice that the ensembles look a little closer than together than the operational runs. They're putting the heaviest snows in through here. Let's just kind of identify this corridor and also in through here. That's the European. The GFS is kind of similar, but it's got more chances of snow out there in the plains. If we look at the chance of 6 inches, that's what the GFS ensemble says. And here's the European. Okay, so this is it. This is all we know up to this point. Let's not make more out of it than we do. We just know there's going to be a big system next week. All right, what about week 2? Well, the models see that system go through, and then we're back onto the week on, week off, right? So the system rolls out. It leaves 5, 6, 7 days of drier weather in through here. This is just the tail end of that system. We go back over wetter west again. I think it's just still in that persistent mode overall. From there, temperatures. Let's work our way to the end of this thing here, okay? This is the frost we're expecting late this weekend and early next week. This is the cold air coming in behind the next system. The temperatures, watch this just load up with heat. Today, 90s in parts of the plains. Still quite cool behind that system here east. There we go into Saturday and Sunday. That's going to be a cold morning for parts of the Northeast, but the heat comes back on in the midsection of the country. This is Monday into Tuesday. Now watch, this is when the system's really beginning to gather. I haven't even mentioned yet that we do have the severe weather threat to the south of this next system. We'll watch that next week. This is next Wednesday, and then here comes the really cold air. These are high temperatures next Thursday of 32 Fahrenheit. Now remind you, today it's 72. So we're looking for a 40-degree swing in temperature inside of a week in this area. And remember, 90s here. By the time we get into next week, we're going to be in the 60s, and all that cold air is coming down behind it. So what do the ensembles show? Next 5 days looks like this. There's the cold air day 5 through 10. And then there it is day 10 through 15, which gets you all the way through the 4th, not the 4th of July. Sorry, Halloween. So we'll watch that carefully. All right, last bit. In the last 7 days, we've had tremendous rainfalls down here measured by satellite in southern Brazil. There's just been spotty rainfall and throughout rest of Brazil, and eastern Brazil has been very dry. As we look at the longer term forecast, the chance of getting 2 inches of rain over the next 15 days, well, this is the 90 to 100% chance. We're seeing better rains in Argentina, better rains throughout Brazil, and some of this is expanding back up here into Mato Grosso. Later today, we'll get a new update from them on their planting progress. I still expect them to be above the 5-year average. We'll put that in Monday morning's video. You spent a lot of time with me today. I appreciate it. Have a great rest of your weekend, and we'll talk on Monday. Thanks.